not billion, but I don't know, anyway, it's very small, yeah? So should we ramp it up a little? Should we make the gravity a little stronger? Oh! That woke you up, right? Right, so we would take that, right, and we would go, the frequency would just be this guy minus this guy, right? So now let's do one where there's a real shift, right? Okay, now G is going to be 2.5 times 10 to the 13 meters per second squared, somewhat more than 9.8, yes? Right, so near a black hole, it's probably, there's a place where there's that much, right? Okay, so now, of course, never mind that radios and buildings wouldn't exist, right? But just change your 9.8 to 2.5 times 10 to the 13th. Yeah? Just pop them in there. I'm going to go second entry. I'm changing my 9.8. Insert, is it 2.5 times 10 to the 13. You guys are being very quiet. Do you get like a big number? I'm getting, my number that I get when I do this is not that anymore. It's 8302222. Is that right? About 8 million hertz. Is that what you get? Yeah? So now the question is, what are they tuned to at the top? Well, isn't it going to be about 8.3 megahertz less? Yeah? Because it's a low clock, right? We're looking down at the thing. It's down there. We're at the top. Never mind that we've been destroyed by the gravitational field, right? We've just been ripped apart by the gravity, but don't worry about that, right? Okay, let's just worry about what that new frequency is. And the new frequency is going to be 93.4 times 10 to the 6th, right? Minus 8.302 times 10 to the 6th, right? Which is going to be 85.1 times 10 to the 6th hertz. So just remember that if you're ever near a neutron star or black hole where the gravity has crushed you out of existence, okay, and they say that the frequency of their radio station, you've got to adjust for elevation. And as you go up and down hills, your car is going to have to like adjust that frequency. Yeah? And then, you know, if you spend a lot of time at low elevations and then you come back up, you'll be younger than your twin. Because low clocks run slow, right? Yeah. So if you got a twin and one of you lives really down low and one of you lives up high near a black hole where it would be impossible to live, right? Then that would be, you know, a big problem, right? Just remember that, you know?
By how many years?
You could in certain situations, right? I mean, here, what's the shift here? The shift is about 10%, right? So when you get to be 80, they could be, you know, 72 or something like that, right? Yeah. But you could have a bigger shift than that. Not that you could really live there, right? Your best bet is to go close to the speed of light and then come back, right? Yeah, Danny.
I don't get how that would work. Like, doesn't your body just like age?
I know. Doesn't your body age? No. Time itself travels slower in your dimension. It's bizarre stuff. Yeah.
Does that mean like your face is less wrinkly?
No, you would be younger. Cheese would mold slower. Clocks would tick slower. Time itself travels slower. It's not like it just affects clocks, right? It's weird. It's weird stuff. Isn't it weird? Yeah? Yeah. It's going over my head too. I'm just pretending like yeah, I understand it. Yeah, go for it. Oh! All right. We already got that. Whoa, same thing. I just didn't make it an example. Okay, so try this one. Here's another one. You can just try this one. You could put it in your notes if you wanted to. You could put it on that note guide if you wanted to. You could put this one down here, right? So two trombonists, right? One at the top of a 250 meter tall tower, one at the bottom play what they think is the same note. The one at the bottom plays 256 hertz, and here's a beat frequency of 5.2 hertz. What that means is that the other frequency here is 5.2 away from it, right? Now, if it's a high clock, is it high or low? It's high, so the other frequency is 261.2 or something like that, yeah? Is that what it is? Yeah, that's what the frequency is, but the 5.2 is all we need, right? That's your delta F, it's 5.2, F is 256, right? 215 is your height. You're trying to solve for G, right? So see if you can set that thing up. First, write this down in your underneath here. You could just write it in this space right here. Yeah, 5.2 is a change. That's the difference, right? So when you're hearing wah-wahs, beats are wah-wahs, right? The wah-wahs are the number of frequencies that you hear, the per second, right, is the difference in frequency. So they're a lot when you're far away, not so much when you're close, right? And 0 when you're right in tune, right? So I'm just going to put this guy here. If you're clueless, hopefully you're clueful and you can put numbers in. The 5.2 goes over there. That's your F, right? This is 256, right? G we don't know. The change in height, what's our change in height? 215. And then C squared is just C squared, right? So 3E8. 3 times 10 to the 8th squared. And we're at the bottom of the tower. Do we hear them up above? Do we hear them as sharp or do we hear them as flat? Do you know what sharp and flat mean?
From the top, it sounds flat.
Well, the top is high, so isn't it a fast clock?
Sharp.
So fast is sharp, right?
But if they're playing, if you're hearing it from the bottom.
Yeah. Well, if you're at the top hearing the bottom, you're going to hear them as flat, right? The person at the bottom hears the person at the top as sharp, right? Okay. And then you know, little thing here. The top player, if you're down at the bottom, you say, "Gee, you're not in tune." What do you tell the top player to do? Slide out or slide in on a trombone? They're sharp, so they need to slide out. Don't they need to flat themselves? Now, is that going to make sense to them? No, to them they hear you as flat. Maybe it does. And then if they slid out, they'd hear you in tune. Is that right? So it does make sense to them as well, right? That's kind of weird, isn't it? You'd both do, if the one person would do the same thing to put themselves in tune. It's good to know. Yeah? Yeah, go for it. I just love that, man. You just got to put that in there, right? Put a random sound effect in your slideshow. Whoops. Whoa, what did I do? Oh, that's sad. We got to go to the last. Come on, we got to see that last animation. That's pretty good. Ah! She's like talking on her cell phone, so I just thought. Have you ever done that? Okay, random thing. You see somebody talking like in a grocery line?
I think that's funny already. Yeah.
No, you can't laugh yet. That's pre-laughing. It's very disrespectful. Okay. You see somebody talking like in a grocery line, talking on the phone? Just walk right up to him and get really close to the receiver and just go, and then just walk away. Right? And you know that they're going to have to spend like the next 10 minutes explaining to the person. No, it was just some guy. No, I don't know who he is. No, he just walked up. Yeah, no, I was standing here, and you know, it's like that's gonna be their conversation, right? Did they ask who was screaming? Don't do it if they look dangerous, though. They might like, you know. That's right. All right. All right. Yeah, this is fun, right? Okay. Now, on the other note guide you've got on the back, there's expanding space. This is the important stuff. I'm going to get to this first. The distance ladder, if we don't get to that so much. Not as important. Well, you know, maybe we can finish up next time. But this is a paradox, and this is